So today I'm going to talk about the three-scale API management and the Istio service mesh integration. So we will talk about how the integration used to work until recently with the use of Mixer, and what's changing now that we have WebAssembly in the mix, and that's the future of Istio. We're going to talk about that. I want to take you through a few slides first on the different kinds of traffic management patterns that we have for service mesh and API management, how to decide what's the right choice to make, when to use each of those particular patterns, and when it is appropriate to use both. And then if sorry, if you do decide to use both patterns, as is very likely in a real world scenario, how you would do this integration with with existing technology. So we'll talk about how it used to work with Mixer, and then we'll talk about how now that WebAssembly is in the mix, how the integration has changed. And then finally, I want to do a demo of the three-scale integration with Istio. Okay, so uh, API management traditionally thought of as the north-south model. Your traffic flows from the north to south. Your client is external, and you have a gateway which acts as a reverse proxy to protect your backend services and APIs. Right. So you have typical security at the gateway. You enforce your rate limiting, your security, your monitoring, reporting. Everything happens as part of the ingress to your applications. Right. So this is what is thought of as your traditional API management capabilities. Now, for managing external clients, it's a very good example of how you would use this. Your API consumers are very clearly accessing it via HTTP protocol, and they're external to either your particular organization or to your enterprise itself. And then you would have your different API backends, API technology, technical concepts of your APIs, and then you would package them into API products, which could be with one or more of these backends packaged together into intelligent plans and subscriptions that you would then provide your API consumers to then use the right security and the right plan to access your APIs. Right? So, from an API management point of view, we are very clear where the boundaries are and how the access works from from north to south, from the client to the server. Right. With microservices, the patterns are a bit more jumbled up because the interaction now, instead of happening outside of a boundary or outside of an organization, it happens as an interaction. So there is a lot of chatter between different microservices that are deployed, and that means that you have hundreds or even thousands of services that get deployed and that need to be managed and scaled. And there is a lot of network of services that need to be managed, which means that you need more of a east-west kind of architecture pattern. East-west is communication between services. Even if you don't talk about external services, access to your APIs, or how to distribute your services that you developed with a microservice architecture to your external audiences, you still have a lot of things to manage internally within the communication between your services within a microservice architecture itself. Right? And that's where the concept of service mesh came about. Right. So what service mesh did was provided it with an abstraction of common challenges that you have with microservices. So it provides you with challenges like security and metrics, tracing, fault handling, traffic management, all these all these, instead of it being distributed across to all the services and being replicated in code in multiple services, if what it does is it provides you with this common infrastructure layer with which you would externalize all these as a service and let manage them from a common control plane, and let your service be focused on solving the actual business implementation of the business problems, right? So make life easier for developers. So that's where the concept of service mesh came about, right? So, having said that, there is still a lot of overlap between what API management provides you and what the service mesh provides you, right? So if you think about it, we talked about the API gateway and rate limiting, policy, security, which are common across with service mesh also, where you're talking about communication between services, and you need to rate limit, you need to do some sort of security between those services and things like that. So there is an overlap of some of those patterns that you need to use. Where it differs is, for an API management perspective, you need to think about who the targeted users or targeted personas are for you. So your targeted personas are your API creators and API consumers. So you're talking about the interaction between somebody who provides an API and somebody who consumes an API. So you're talking about formal contracts, monetizations, providing some sort of a developer portal or developer forum, documentation, creating that partner ecosystem, and things like that. And on the other end, with your service mesh, you are targeting it more towards your developers and DevOps. It's more about observability across your services in the mesh, building in resiliency, chaos testing, doing traffic routing, and retries and timeouts between services, creating an ability for you to provide one single business service using multiple microservices that interact with each other. So the way that you make it work is more technical in nature, right? So just to highlight those differences at a very high level, API management is about managing the relationship. So it's slightly more business construct in terms of the API consumers and the API providers, and the business value of APIs. Whereas service mesh gives you a better control on traffic management, security, and observability across the services in your mesh, and more suited for cloud native application development, more suited for your developers or DevOps model inside a container platform. Okay, so when to use what, right? So if you have API consumers, and you are providing these APIs through a set of microservices, and you have both external facing APIs and internal microservices that communicate across, a simple pattern would be whatever is external, whatever is consumed by external consumers, go through an API gateway and are managed through API management, and whatever is communication that happens internally or directly between sets of microservices would happen through an east-west management or with a service mesh. But what is also challenging is sometimes the communication and the boundaries are not clear. So, for example, instead of having one single enterprise boundary, you may have multiple domain boundaries within which you would have to manage the access control between different set of consumers and API providers, and so in that case, you would consider whatever is traffic flowing externally from my domain boundary, managed through API management, and whatever is being consumed within my domain boundary happens within a single service mesh. Okay, so and then how do we distinguish between this kind of intra-domain traffic and interdomain traffic, right? So you have to look at the patterns of how the services are connected with each other. If the services are connected through a single ingress or a single gateway point, and then you are able to orchestrate or synchronize the multiple services from that point onwards, so it acts like a proxy for all of your services. That's the hierarchical model, one is to n model. And then that gives you an ability to differentiate between different consumer groups, and providing access control at that one single service applies it to the whole microservices that you're calling. So at that point, you could provide more formalized contracts there, and you could provide those external facing services to be discovered through a developer portal and through formal documentation. Whereas, if the communication between services is more like a chatter, it's more one to one, and the consumers are usually part of the same team, or they're within the same domain or within the same organization. There is more of a sharing of code, either through the single GitHub repository, or single GitHub organization. Then the contracts become more implicit part of the code, and you're more focused on authorization and providing that transport layer security between services, rather than authorizing who the particular consumer is, and at different plans and things like that. Okay, so that's where your service mesh would be a better fit. Now, with the use of Red Hat integration, what you would see here is that on Red Hat OpenShift you could have both Red Hat service mesh, which gives you that service mesh management to a microservice architecture. And then if you also have some services which you have deployed with a traditional architecture, you could use the Red Hat's three-scale API management for providing that north-south control and north-south API management using the API management platform. Okay, and then think about who your customers are and who your stakeholders are. For a microservices architecture, it's usually the DevOps and the app developers. And for your API management, it's generally the service and API owners that are going to be managing that particular platform. And then for a traditional platform, you have app developers, and for your infrastructure platform, OpenShift or any container platform you use, you have your infrastructure admins and your infrastructure owners managing that. Okay. So that's a very high level introduction about API management versus service mesh, and where they two fit together, and how you can make a choice which to use. Now, what we have seen so far is there is really a close interaction between API management and service mesh, and those two technologies do sometimes intersect, and there is an opportunity for us to make that intersection a bit better. So diving a little bit more into the detail of the service mesh architecture itself. So originally, the way that the Istio controlled the architecture was to have Envoy as sidecars that were deployed with each of your services. So this was at the data plane, and all the requests that were passing through to your service would pass through the Envoy, and then the configuration or policies that you have stated in your configuration would apply there. And then you would have a control plane, which I've shown in the green box at the bottom, which has all of the policies that you are configuring excuse me, for those particular services. Okay, so you had at that point you had different different ways that you could uh, provide these policies, right? So you had a component called pilot, which configures all the data that is required to go to the proxies. You had Galley, which provides the configurations. You had Citadel, which took care of TLS certificates and adding those certificates and providers details into the proxies that are being used. Right? Mixer was one of the main components there. So what Mixer used to do was to directly interact as the communication between Envoy and the control plane at the for each request. So telemetry was collected through there, and policies that are being processed on the fly were actually injected through there. And if you had any additional or custom policies that you built them as Mixer adapters, and then you attach them to Mixer, which meant that during the Mixer processing, it would actually plug in your adapter, and then it would include those policies onto your processing of your request as part of your Envoy, right? So what's the problem with that, right? For every request, you're going to the Mixer. Mixer is part of your control plane. So which means your Mixer became a bottleneck, right? There are latency issues, maybe not apparent in with a small request type, or with with a slightly lower traffic. But as your mesh grows, as your profile of your services and the complexity grows, Mixer becomes a bottleneck for you. It would introduce latency, and there is unnecessary traffic to the control plane happening with each request, right? So these issues were encountered when things started to get complex in the Istio world, when we saw a larger and larger microservice architectures being built. This Mixer became the one bottleneck that needed to be solved. So the solution to this was that Mixer was removed, and there came a completely new architecture, right? So think about how we were solving these issues previously, right? So instead of injecting our configurations, and doing the actual processing of the policies at the control plane, we have an intelligent Envoy that is a sidecar for each service. Why can't we do that at the Envoy itself? So that's the idea behind using HTOD as the policy type. What it does is it pushes all of the policies directly into Envoy, and you could directly use that. So that means any request to the service goes through Envoy, policies applied within that particular container itself, and then the request will be passed on to the service. So there is no interaction between Envoy and the control plane for each request, which leads to a faster processing. So in order to do that, we also needed a way to introduce this extensibility, right? So as we have seen with Mixer, we had the concept of adapters with which we could introduce custom policies into the service mesh. So in order to provide these extensions at the Envoy level itself, there's a concept called WebAssembly that was used. And then with the support of WebAssembly, this particular integration of custom policies directly into Envoy as HTTP filters was introduced. Okay. So what this means is you are now providing all of the custom extensions that you need as part of the data plane itself. So you are injecting it once, injecting it to whichever services needed, and then they are being processed in the data plane at runtime. Right. So why did we settle on WebAssembly? So WebAssembly is basically a bytecode format. So it's executable code that you would be deploying onto the corresponding envoys. It could be it could be written in multiple languages, and it could run at near native speed on multiple deployable platforms. Okay, so Istio and Envoy communities have been using Wasm since Istio 1.5, and it has been part of their platform for around 5 to 6 versions now. So it has matured along with the platform itself, and it also provides benefits like because it lives at the proxy level. There is no single point of contention, and you could scale it to as many services as you want, and as your service scales, the extensions will scale with it as well, right? And extensions at the same time are deployed within a sandbox, and there is a clear API between the extension and your host, which means that it could only get access to certain HTTP requests at certain phases, which meant it provides better security and better isolation for you. Okay, and another advantage of it is you don't have to have it deployed across your mesh, right? You could choose which particular services to deploy to, or which particular namespaces to deploy to, and you could just label it with the workload selector resource, and then it would only apply to those particular services, which means that you could choose which particular web assembly will be required to which particular services. Okay, so a little bit more about WebAssembly. So it actually started as a way to, if not replace JavaScript, as a better way of doing JavaScript for web browsers. Okay, so it became a standard for web browsers and adding extensions to web browsers. And so so the term WebAssembly, right? It had a web API, and it had a JavaScript interface, and it had a core specification which allowed it to be run as virtual machine, binary code in a virtual machine inside the browser itself, right? And then what happened is, there are other projects like Envoy looked at the way that you are executing this, and decided that if they could just build a proxy to this particular web extension, they could then extend the same concept of how we do web assemblies inside a browser to actually work for inside an Envoy, or inside of your HTTP proxies, right? So, and that's why it has been used. So WebAssembly is part of the W3C standard. So it is it is being maintained and managed by different organizations contributing to it, and it is actually a hardware, language, or even proxy independent, right? So it's extendable in all sorts of ways. So you could choose the language you want to write in, choose the hardware on which your bytecode is deployed and run, choose the proxy protocol with which you are going to call these WebAssemblies, which means it gives you a very extendable way to inject your custom code into these sort of WebAssembly extensions. Okay, and then the proxy WASM spec is all about how to provide this particular specification to run this third-party code in a proxy agnostic way. So the concept is to take an application to binary interface. So the concept of taking a binary that could be run and then calling it from within an application, right? So you call it from a proxy, and then you provide it to run within a sandbox, and then inside that sandbox you provide certain only certain rights, and certain protocols that it could call, and it would use that, and it would be able to use that to run this code for you. So limited scope, and custom code that you could run in your applications directly. Okay, so now let's look at the 3-scale and Istio integration. So taken an example, this is a very well-known example in the Istio community. This is the book info example. So you have the product service, and there are basically it consists of 4 different microservices: product, review, ratings, and details. And what it does is basically in case of my example here, what I've taken is, if you look at the way that the booking, for example, is structured, it's the 1:n hierarchical pattern that we talked about earlier, which means that you actually have that particular product service, which will be the ingress point for all of the other services to be called. So naturally, it became a candidate for us to enforce your gateway rules, provide a product API formally, and manage it as an API for access to to your outside consumers or clients to access your microservices. So this is an example that we have taken to leverage both the service mesh, which is all of the services that we have shown here that run within the mesh, and then the API itself that I'm using to expose this particular microservice to outside organizations. And then so how do your developers access this, right? So with I'll first talk about how we do it with Mixer, which is the traditional approach that used to work until the release of Service Mesh 2.0. Which is that you have an Istio ingress that leads to your product service, and within the product service envoy, you have the connection to the Mixer for enforcing policies. So 3Scale actually developed an API management mixer adapter that would connect to the 3Scale control plane. And then through the use of this particular mixer adapter, anytime on the data plane a request is made through the mixer and through the adapter, a connection is made to the API manager, and rules and rate limits and plans that you have set within 3Scale API manager platform were in turn enforced within the data plane. So the advantage you see with this approach is you didn't have to put another external gateway. We didn't have an API gateway in front of the service mesh, and we could leverage the same envoy and the same Istio control plane to plug in the policies and configurations that we have created within the 3Scale API manager directly to be enforced at the data plane level, right? So it was a very efficient solution. But like I said, the solution depends on using the mixer, right? And Istio has moved on from the mixer to the WebAssembly. So now how does this work now? Now API management has to use the Envoy filters and the WebAssembly to provide the same functionality that it used to do with Mixer. So the good thing is it now pushes the API management also as a WebAssembly extension directly onto Envoy. There is no need to connect to the API management control plane for every request. All of the connectivity happens within the Envoy plane itself. And the 3Scale WebAssembly works deployed within the Envoy sidecar itself, which leads to faster processing. Okay, and so if you see here, this is how the processing works now. So you have the 3Scale auth WebAssembly that is called directly from within the product service envoy, and then the 3Scale policies are enforced directly within that auth, and then if the 3Scale authentication is successful, authorization is successful, the request passes on to the product service. Right? So again, exactly the same as before, but a much better approach and much more extendable approach to how you can add policies here. Okay, so let me show you a quick demo. Let me just spend a couple of minutes trying to see if there are any questions in the chat. All right, okay, no questions, but I can see I have become quite dark. Actually, it started raining here. Let me share my screen again. Okay, friends, so hope you can see my screen now. So if you can see, this is the API management platform that I have used. This is running on OpenShift. can you see my OpenShift container platform console now? Can anyone please confirm that? Okay, let me share. Thank you, Damien. Let me share my whole screen so that we don't run into these problems. Okay, yeah, it looks like it's working now. Okay, I hope you can see this now, right? Yeah, perfect. Okay. Yeah, so what I have done is I've taken the same example. I'm going to show you first how it is running with Mixer, and then I'm going to show you how it's running with WebAssembly. Okay, so I have my Istio system within which I have deployed my service mesh. Now, for the purposes of this particular example, I have actually used the service mesh control plane, which is actually running on version 1.1, which actually by default use the mixer. So you don't see mixer here, but the type of policy was by default only mixer available at that point. And so what happens here is if I actually show you the application, let me just show you the application. Yeah, so same application that we have seen with the ingress and the product page details and reviews, right? What I have also done as part of this is I've actually configured an API management platform on 3Scale, used this particular product and defined a product plan for it. And using that particular plan, if you can see here, I have actually got my plans for it, and using this particular plan, I'm actually configuring different applications that could run this. And I have an example developer here which is actually using this plan and a unique user key in order to connect to it. So if I then make a request, now let me make a request first without providing the product page, and without the user key, and you could see that there is a permission denied because 3Scale handler tells me that there is no authentication providers, right? Authentication credentials provided, which means that from on the data plane, your request going to an Istio ingress gateway, as you can see, that's where it's going to an Istio ingress gateway directly to the product service, through the Envoy calling the mixer calling the 3Scale authentication, and then deciding that no, 3Scale deciding, okay, there are no credentials, so deny this request, right? If I provide this request, then you can see that it succeeds, right? I'm trying to run this a few times just to show you, how it works. And then, sorry, jumped a little bit. And then if I come in here and look at my traffic, you could actually see that the traffic actually is shown in my 3Scale API management platform as well, mainly because I'm making this request as an application of API management platform and flows through the API management product itself, right? Also, I could see this particular tracing of my particular request going from the Istio ingress to the product page, right? What's interesting is if I now try to find the traces, you could see that I'm getting around 30 to 32 milliseconds request response time. And what's interesting is for each request, you actually see that the Istio mixer is being called, and the mixer in turn calls my 3Scale authentication adapter, and through which my request is authenticated to the 3Scale backend API, right? All well and good. And you could find this same traffic appearing here as well. So if you see here, there are the traffic is also recorded in my Kiali and my Istio observability. So my observability works in Kiali, my tracing works in Jaeger, my API is managed through 3Scale. All of that happens seamlessly in a single platform, right? Now coming to the future, right? Coming to what we have done in the next gen. Same concept. I also have the Istio system where I have installed Service Mesh, but this time I have gone with installing the latest version of Service Mesh, which is version 2.1. And if you see here, the policy type that I'm choosing is istiod, which, as we talked about, is the type of policy which actually injects all of the policies processing directly into Envoys, right? And so when I do that, and if I look at my Kiali system again, I should be able to see some requests that came. Yeah. So exact same example, exact same ingress, product page, details, reviews, and ratings, and the same steps. And what I have also done is I have kept my three scale configuration exactly the same. So if I go to my three scale product, you could see that I have this book info product, which is again configured to run with Istio, right? Configured to run with Istio. And I also have the same kind of an application plan that is defined in three scale, a basic plan that is defined in three scale. And I created an example application which uses a unique user key now. Okay, exact same scenario. Now I make a request. Now let me also try the same thing without providing the user key. Let me make a request, right? Access forbidden. So you could see exactly the same thing, and I'm able to now restrict access to my application from using the WebAssembly extension. And if I provide my user key, the request succeeds. And if you see here, I try it a few more times. And if I go back to Jaeger just to show you the exact same traces, you see here it's around 20 to 27 milliseconds. So for a single request, you would not find much of a difference because it's still going to go and we're going to call the VM. But if once you scale it up to multiple threads and multiple requests, you will begin to see the differences between the efficiency of WebAssembly versus versus the efficiency of the mixer. And if you see the request profile here, there is no mixer, right? It's going directly to the different services, right? So within the service itself, except for the one proxy that is being called, and this is the proxy that actually tells you that it is making a request through the sidecar to the backend three scale authentication. You would have no idea that it's going beyond this the sidecar and processing that. Yeah, right. And in terms of visibility, you would actually find that you would actually find that the usage is also recorded here in three scale. Usage is also recorded in three scale here, just like it did previously. All the rules from three scale perspective applied exactly as is. The changes are on the service mesh side. Okay, so I'll just spend a couple of minutes explaining the changes on the service mesh side. So in here, if I go to my Istio system and I look at my pods, you could see that there is a Istio policy and there is this Istio sidecar injector pod, right? So the policy pod is what is being called for each request, right? And then I have a three scale Istio adapter that's running as a separate pod here. So this is my adapter. And so if I look at the logs here, this is what is actually making a request back to my three scale and trying to get that particular get the particular authorization from three scale before letting the request pass, right? This is how it works with mixer. Now, coming to when I use Istio and when I use WebAssembly, there is, as you can see here, there is no policy pod here, right? It's all done through Istio directly to the Envoy, and there is only a single WebAssembly cache. And what it does is, how we can define which particular extensions can be applied to which particular namespaces. I have configured my WebAssembly extension to apply to the book info namespace. So it is going to apply it to that particular namespace. And because this is a controller, it is going to make periodic requests and update that particular WebAssembly, right? And where is the logic then for me to connect to 3scale? It's actually within my product page pod itself, and within that, if I go to the proxy container, this is where you would see the requests being made to through the sidecar uh, to the 3scale wasm extension. So the 3scale wasm, in a sense, running as a VM within the binary of Envoy itself. So the logs are actually coming directly into Envoy as an Envoy filter, right? So vastly more efficient. Okay, and the last thing I wanted to show you was the custom resource definition of how I have configured my 3scale to work with Istio. So I have to define a service mesh extension. So in this particular service mesh extension, what I provide is information about, scroll down. Sorry. Yeah. So information about my backend, the URL of my backend, which is the 3scale API that is going to authenticate the requests, my service that I'm going to authenticate, my credentials and where I can find the credentials in the request, my service ID for that particular service, the mapping rules, and a unique token for connecting to my service in 3scale, and also my 3scale admin portal, from which it can pick up the service configuration and configuration changes automatically, and the phase in which my particular WebAssembly filter is going to be applied within the HTTP processing, and the workload selector. So we talked about this. With a workload selector, you can decide where you want to apply which particular namespaces you want this particular sidecar to deploy this WebAssembly extension. It's going to do that only for the application called product page, right? So if I go to any of my other applications here, and this could be a label to a namespace or a label to an app. But if I go to any of my other ones like log, review, you would see that they don't have the extension loaded here, right? And that's because the Istio only pushes this particular WebAssembly extension into using the workload selector to the workloads that I have asked for it to deploy. So vastly more efficient than how we had to do it with Mixer. Okay. So let me pause here and see if we have any questions. We have 5 minutes. Let me stop sharing my screen. Okay. Thank you for staying on till the end, and I hope you found the demo and the presentation useful. If you have any questions, you can either type it, or I don't know if I could provide you access. Yes. Yeah. So the WASM extensions for Istio, they could be written in 4 languages. There's Rust, there's C++, and Solo IO is actually worked on a custom language called WebAssembly extensions.io, and then there is one more language. I forgot. I think it's probably Java. I need to look it up, but there are four languages in which you could write instructions now. This particular example that we have used is written in C++. Oh yeah, Go is the fourth one actually. Yeah, yeah, yeah. Go is the fourth one, and in fact, there is no problem with writing WebAssembly extensions with Go. Some of the other work that we are doing to provide WebAssembly extensions to some of our other filters that we are developing, we are writing them with Go as well. Thank you. Any other questions? Thank you very much, everyone. And if you go to the Red Hat booth, we have provided some links to, some of the examples that we have shared here. And in my slide deck, I actually have a few links to how to develop your own WASM extensions, supported languages, example code, and things like that. Do try them out. And and we also have an ebook for service mesh versus API management that would cover some of the initial topics that we covered in more detail. And I hope you could find that useful if you download it. Okay, and thank you very much for coming to the Red Hat workshop. Thank you for staying engaging and the questions. And have a happy rest of the API days, Paris. Thank you very much.